be 30,000 divided by 120, you know?
Right. Okay, number 11. Hmm. 1 micron equals 10,000 angstroms. Then 100 angstroms is what percent of 10 microns? Do this in 2 steps. Figure
Yes.
out what percent 100 angstroms is of 1 micron.
100?
100th. So that's 1%, right? So 100 angstroms equals 1% of 1 micron. So what is 100 angstroms? What percent is it of 10 microns?
I want to say 10, but that's not an answer.
Well, they were nice to us here. They left the trick answer off there. You're going in the wrong direction. In other words, if 100 angstroms equals 1% of 1 micron, then 100 angstroms has to be a smaller percent of 10 microns.
Would it then be 0.1? Because it's only 10, so you move it 1?
Yes, 1/10 of 1%. Let's go to 13.
Mm. One second. I'm just calculating.
All right.
It's the difference divided by the original price times 100, right?
Yes. So we
So it'd be
have
900.
10,000 minus 1,000 divided by 1,000 times 100 to convert it to percent.
I said it was 900.
Okay, good. We can either do 14 or not. It's a fill in the blank.
Well, that's fine. Maybe we can try it.
Yeah, let's do it. Even if this was multiple choice, we'd have to do exactly the same math.
Would you pick numbers here?
Well, there's only one problem with picking numbers here. They've given us a number. So we can't just pick any random numbers because it's not going to result in this $45. So that's the key as to when you can pick numbers and when you can't. If they don't give you the key numbers, you can pick numbers. But if they do, you can't. We can experiment a little bit to see how we might do this problem. Suppose the jacket was $100. And he meant to reduce it to 85, but instead he raised it to 115. Well, that's $30 too high.
Mm-hmm.
So we need to go higher.
Then 100, yeah.
If it was 200, it would be $60 too high. So what do you figure the price is going to be where it'll be exactly $45 too high?
Maybe 150?
Well, let's try 150. And that's the best way to do it, is kind of narrow in on it. It didn't take me too long to narrow in on 150. So 150 was supposed to be reduced by 22,
22.5.
right, which
Right?
would have made
Right?
it 127.50, and instead he increased it by 22.5. So doing it that way was actually pretty easy. It wasn't the algebraic way. We could set up an algebraic equation here,
Yeah,
but
but I'm not very good at that,
well, you
so...
know, most people aren't. It really, to me, anytime you can solve these by doing what we just did, which is kind of experiment around with a price or two, or picking numbers, or back solving, or one of those techniques, almost is always easier than the algebraic technique. It's just too difficult to try to figure out those algebraic equations. Number 15.
Okay. Okay, well, she needs to answer 64 questions total to
Okay?
get an 80% of 80
Mm-hmm.
questions.
Okay?
And she's already answered 45 correctly. So she's missing 19. So you need to figure out what percent of 20 equals to 19.
So 19 divided by 20 equals what? Remember the little trick of trying to make the denominator 100, and then that'll convert it to percent immediately.
Yeah, so you multiply it by 5.
Uh-huh. So 5 up top, 5 down the bottom. That gives us 95 over 100, 95%.
Mm-hmm.
Okay, that's all for percentages. Oops, I don't want to go there yet. Okay, ratios and proportions.
Okay, so it says if 3/4 of employees in the supermarket are not college graduates, that means that 1/4 is college graduates. So if you need to find the ratio,
Mm-hmm.
would it just be, I want to say 1 to 3. Or
Well,
3
you want to
to
say
1.
1/4 to 3/4, right? Oh, no, excuse me. Yeah, yeah, because 3/4 are not, 1/4 are. They want the ratio of graduates to not, so we take 1/4 divided by 3/4. The 4s, once again, you can cancel them because they're both denominators, and you get
So it's 1 to
1
3.
to 3. Mm-hmm.
Okay, good. I was like for a minute, no, really? um, if a divided by 9 is equal to 10 divided by 2a, what is the value of a squared? Well, You need to get the A's on one side.
We're going to cross multiply. Whenever you have a fraction equals another fraction, usually the first step is to cross multiply.
Then it's 90 divided. So you don't divide them?
Well, you multiply 9 times 10, you multiply a times 2a, so
And then that just takes
2a
out
squared is
the
equal to
divided
90.
sign?
So a squared is equal to 45, d. It's asking for a squared, not a.
Oh, I know. I'm just saying, like when you do that, it just eliminates the divided sign.
Well, what you're really doing is 2 steps in one. In other words, if I didn't have the term cross multiply, what would I do? My first step, I'd multiply both sides by 9.
Mm-hmm.
My second step, I'd multiply both sides by 2a.
Okay.
So it's really just 2 steps in one. It's multiplying by this denominator, and then it's multiplying by this denominator. To save time, they come up with this term cross multiply. Yeah, all right, number 3 is a good.
If 80% of the applicants to a program were rejected, what is the ratio of the number accepted to the number rejected? I mean, it would be 20 over 80.
That's right, 1 to 4. Now, I'm not quite sure. Well, you're not going to have these kind of questions anyway.
No.
You're going to have multiple choice. In other words, would this be marked incorrect on the GRE? I don't know. Probably. They probably always want it simplified.
Yeah. I mean, you would realize that because you would have 5,
Uh-huh.
you know? You would
Yeah.
have 5 answers. So
Right,
it would be
right.
easy to figure out.
Okay. Scott can read 50 pages per hour. At this rate, how many pages can he read in 50 minutes?
Well, you would say 50 divided by 60.
Okay.
But then
That's
you
the
know how many
portion.
he reads.
That's the portion of the hour, right?
Yeah.
Okay. Now, to come up with the answer, let's see what the easiest thing to do here is going to be. Well, we got 250 divided by 6. Moment we get that number, that's all we need. In other words, try to recognize how far you have to actually do the arithmetic sometimes. I mean, as soon as we get 41, we don't care whether it's 2/3 or whatever the rest of it is. There's only 141 on this answer. See what I'm saying?
Mm-hmm.
Okay.
I mean, you could have reduced the thingy with 6, I guess, or 5.
Not so easily. I couldn't unless I missed seeing that. How would I do this?
Well, 5 goes into both.
Oh, 5 does go into 12. Yeah, you're absolutely right. Yeah, you're right. So I could have done that, and then I have, once I cross out the zeros, I can't do it anymore, huh?
No.
That's an interesting little trick. Yeah, that's very good. Thank you for pointing that out, because the best move here is not to cross out the zeros.
I mean, I would just have said, well, 60 goes into 50. Well, so it would be 10 and 12.
Right, so it would really be 10 times 50 over 12, and now that's done a lot easier.
And it just it just makes, because then it's 512, you know?
Yeah, then it becomes 5/6 of 50. So it's not that easy to do that. You still have to end up doing that, I think.
Okay. Well,
But
I just thought it was worth trying.
yeah, well, no, you're right. I mean, anytime you can find little shortcuts on this arithmetic, it's worth doing, I think. Okay, let's see. Number 5? That was 4. Let's do 5.
If all the members of a team are juniors or seniors, and if the ratio of juniors to seniors on a team is 3 to 5, what percent of the team members are seniors?
So what's the ratio of the seniors to team members?
Well, you don't know how many people are on the team.
No, but it's a multiple of 8. In
Yeah,
other words, if this is a ratio of 3 to 5, then there's either 5 seniors on an 8-person team or some multiple of that. But regardless, it's not going to change our ratio. Our ratio is going to be 5 divided by 8, which is 62.5. That's one that's worth memorizing.
yeah,
8.
it's the part out of the whole times 100.
What's 1/12 or 1/8? Excuse me, equal to 12.5%. Okay, 2/8, you know. Well, 3/8 is going to be halfway between 2/8 and 4/8, so it's got to be 37.5%. And then 5/8 goes up halfway between 50 and 75%. So knowing your eighths is probably worth memorizing. Okay.
Now of the 3 angles in a triangle are in the ratio of 1, 1, 2. Which of the following statements must be true? That the triangle is isolated, that I would say that was true, because that means one side.
Isosceles, Isosceles merely means two sides that are the same. So that one has to be true.
And that the triangle is a right triangle is not necessarily true.
Well, it definitely is not a right triangle. For something to be a right triangle, the Pythagorean theorem works both ways. If something is a right triangle, the Pythagorean theorem holds true, and if the Pythagorean theorem holds true, something is a right triangle. So 1 squared plus 1 squared would have to equal 2 squared if this was a right triangle. And it's not. I mean, it doesn't. It equals square root of 2. Yeah. So B is not true. How about C?
I can't remember what equilateral means. But is that where all the sides
all three sides, right. All three sides would have to be equal.
That's not true either.
And all three angles. Incidentally, in an isosceles triangle, the angles opposite the same sides are also equal. In other words, that is equal to that. Okay. It's the ratio of the circumference of a circle to its radius. What's C equal to?
2 pi r.
So how would I find out the ratio of the circumference to the radius?
Would you move 2 pi away on the other side?
We want the circumference divided by the radius, right?
Uh-huh.
Well, and substitute for circumference. Instead of c, let's use 2 pi r. So that ratio is 2 pi.
Yeah.
Okay.
What is the ratio of the number of freshmen to sophomores to juniors to seniors on a college basketball team? The ratio of the number of freshmen is 4:7:6:8. What percent of the team are sophomores?
So you can use the exact same strategy that we
Well, there's
used
88
before.
students.
Huh?
There's 88 students, right?
No, just add up these four numbers, and we can use that as our total.
Sorry, I multiplied them. 28.
25. So there's 25 students. How many of them are sophomores?
7.
What percent is that?
28.
Good. In other words, we didn't have to pick numbers or guess on the totals at all. These ratio problems are always this divided by the total of those numbers added together. Or in the case where there were just two of them, back here on number 5, it was 5 divided by 3 plus 5. All right. Let's see. Okay, now this is a little different. Here the ratio of Spanish to French is 7:2, and there's 140 students taking French. How many are taking Spanish? So what ratio can I use? Equation. An equation that has a ratio on both sides.
I'm not sure.
Okay, we got French is to Spanish as 7 is to 2 as 140 is to x. So this is the equation we have to solve.
So, it just looks weird. Because it says the ratio of the number of students taking Spanish to the number of taking French is 7:2. So wouldn't S...
No, I got it wrong. I got it backwards. It's 7:2 is Spanish to French. So this is x over 140. Excuse me. I had it French to Spanish.
I just wondered if I read the question wrong.
No, I had it wrong. I was thinking the French to Spanish was 7:2. Spanish to French was 7:2.
But
So,
then would you press multiply?
right. What it means is that there's going to be more people taking Spanish, about 3.5 times. And in fact, I could solve it like that. I could realize that 7 is 3.5 times 2. So the people taking Spanish must be 3.5 times 140. And notice that's exactly what this is going to produce. I multiply both sides by 140. I get 3.5 times 140 equals the x.
Yeah. You know what I did? I got the same number. I just did it differently.
Okay.
I just said that 2 divided by 140 is 70, and then I said 7 times 70 is 490.
Okay. Yeah, that
Is
works.
that wrong? Or, because I got to the same number.
Yeah, no, whatever works. Whatever works. These ratio problems, there's lots of ways to do them. I suppose the biggest thing to realize is that when you see the colon sign, you can use the fractional bar. In other words, A colon B, I'm not sure if in Denmark you even learned this colon sign. That's the same thing as saying A over B equals 3 over 5.
I can't remember from like back then.
And then A over C is 5 over 7.
What is B over C?
What is the value of B over C?
Wouldn't you have to cross multiply first and then
Okay. Let's cross multiply the first one. We get 3B equals 5A.
and then the next one you get 5A
We
or
get
7A and then 5C.
equals 5C.
I would turn that around.
Well, notice we're looking for B over C. Okay,
Yeah,
so
I could get the A's on the same side in the two equations.
yep, and then just equate them, and then we'll be able to solve for B over C. So up here, A is equal to 3B over 5, right? Down here, A is equal to 5C over 7. This A is equal to this A, so 3B over 5 equals 5C over 7. And now is all we have to do is rearrange this so that we have B over C.
Would you have to cross multiply again?
Yeah, we could do that. That works. 21B equals 25C. Now divide both sides by C and both sides by 21. So B over C equals 25 to 21.
So D.
Yeah. Okay. Why don't we go to our tests? Let's see, we got through 11 of that. And we want to go, you want to do just data sufficiencies?
That's fine.
Okay. Let's see, I've got, how many of these tests? I've got 5 of them. 1, 2, 3, 4, 5. We could just do all of the tests, all of the data sufficiencies, and then if we still need more problems to do, we can come back later. So let's just go through these and search for the data sufficiencies. Excuse me. Oops, wrong one. Don't need that one anymore. And I want Peterson's. Nope. Next page. All right. How many do we got here? We have one right here. Oh, no, that's the nickels, dimes, and quarters. Let's talk about that briefly, too. Again. These are easy problems to miss. And the reason is because if we treat this as a continuous function, in other words, if we said the number of quarters is X times 25 cents plus the number of dimes, let's call Y, times 10 cents is equal to 205. If we view that as a continuous function, then neither one of these tells us the answer. The only reason each of one of these tells us what the answer is because there are not an infinite number of solutions to that. Because x and y have to be whole numbers. Because x and y have to be whole numbers, this becomes a counting problem. We need to figure out what combinations work. And we went with 7/4, 3 dimes, or we could reduce that to 5/4 and up this by 5, 8 dimes. You could have 3/4, 13 dimes, or you could have 1/4 and 18 dimes. And that's really the only 4 solutions. And that's the only reason number 1 gives you the answer, because of those 4 solutions. That's the only one where quarters are more than dimes, and that's also the only one where there's exactly 10 coins. So be careful on these coin problems. They all tend, especially data sufficiencies. If you see a data sufficiency coin problem, realize that you're looking at a discrete number of solutions and you want to try to probably list them out, as opposed to treating it as a algebraic equation like that. That is the correct algebraic equation, but there's a lot more to this problem. There's the fact that x and y have to come out to be whole numbers. Integers, in other words. All right, let's find all of the data sufficiencies here. Okay, 26. Oops, hold on. Huh?
Where people plan to rent a summer cottage, appointing the rent equally, what is the total amount of rent for the cottage? Well, you can look at number 2. That's pretty easy to answer.
Okay.
And the answer is no.
Hold on. Am I missing something? If each of them have to pay equally, and 3 of the 4 people paid $2,400, they each paid $800. So the 4th person would have to pay $800.
I forgot about the equally part.
Okay. So 2 is a yes. It's amazing how many in this exercise, in this Peterson's, where 2 is the simpler one to analyze. Almost everyone we've come across has been like that. I'm always writing 2 ahead of 1.
If one additional person were to join in renting the cottage, each person would pay 20% of the total rent. Well, I mean, since you don't have any numbers or anything on
Does
the
that give you any additional information over the stem?
No.
I don't think it does. All it means is that if 5 people are renting it, they're going to...
20%, if 5 people, they pay 20%, that just means, oh, well, then the rent is 100%, you know?
Right. In other words, they're still going to split it up equally.
Yeah.
So 1 doesn't really give you any additional information. Let me pull up the answers here. I want to make sure we check these answers because they can be pretty tricky. They really can, where sometimes it seems obvious what it is, and it just isn't that. So 26 should be B, right? Yeah, all right.
That's what we think.
Yeah. Okay. All right. I'll search for data sufficiencies. Let's see. I just opened the answer key. Is that the one we just did? Yeah. Okay, we got lots on this page.
How long does it take Sam to eat an entire pizza? Well, here it's 1.
Ah, finally, a 1 that's easier to analyze than the 2.
And I would say the answer is no, because the fact that Thomas can eat the pizza in 8 minutes doesn't really say anything about Sam.
No, nothing at all.
And then Sam and Thomas together can eat the same large pizza in 6.5 minutes. Wouldn't this be like sort of like a work problem thing?
It's exactly a work problem.
Yeah, since there are only 2 people, you could technically use the A plus B or 8.
You're going to use this formula. 1 over the rate of the first person plus 1 over the rate of the second person equals
Yeah.
1 over the total time.
Yeah. Well, do you remember I told you that there was this formula they gave us for if it's only 2 people?
This is it, isn't it?
No, actually not.
Really? That's not it. Oh.
No, 1 second. I want to say it correctly to you. I mean, I remember it, but, you know, right when we're talking about it right now, I'm like, oh, no, what is it?
Well, it is key to understand here that we don't have to solve this.
Oh, I know. I just wanted to ask if that was kind of like, so the other formula they gave us when it's combined work for 2 workers is AB divided by A plus B.
Which is
And
sum
the
of
one,
those two. That's what 1 over R plus 1 over R is. If you find a common denominator, oh no it isn't, excuse me. Oh, it's the inverse of that. In other words,
yeah,
we would end up with A plus B over AB, but we're looking at the reciprocals here. So that's why you end up with AB over A plus B.
yeah. So that's why so they say to use the
Okay.
1 over R plus 1 over R, you know.
This can be used
That's
for 3
what.
workers also. In other
Yeah, so
words,
that's what they're saying is that if there's only 2 workers, you can use that AB
okay.
divided by A plus B, and if there's more than 2 workers, you can use the other one.
Right. Okay. So
Let's just use your formula for this one, because I know both of them. I just wanted to say, like,
okay. So the question is, 2 alone doesn't work, right?
no, because you don't know anything about any of them.
Maybe Sam eats 99% of the pizza and
Yeah.
eats it in 1 minute or 1 minute, you know. So that doesn't
Yeah.
tell you anything about Thomas's rate. That's just their combined rate.
I would say that you can solve it with 1 and 2, because you would have 1 over T, and you would have one of the 1 over R's.
Exactly. Exactly.
Because 1 over T is 6.5, 1 over 6.5.
Right.
And then, yeah, so you can solve it. So that would
And then you know one of the R's, so you can solve for the other R.
Yep.
Okay.
I forget that we don't have to do it.
Well, you know, that's a huge part of data sufficiencies, is not doing them. In fact, I kind of made a mistake yesterday in our session when I solved it. The one about the 1,000 and the 600.
Yeah, and that's
I accidentally solved it, and I didn't really intend to, and it was only after thinking about it I realized, nah, you know what, I shouldn't have solved that. I should.
Well, yeah, because for me it was like I wouldn't have found those numbers,
I
like
know.
that.
I know you found that troubling, and I started thinking about it and realized, well, you didn't have to do any of that math, really.
Yeah. Well, just because I know that when you're working under pressure, your brain works sometimes not as you do when you just sit at home, you know?
Mm-hmm. Right. Okay, so how about number 30?
So y is bigger than 0, and x is bigger than y.
Is x bigger than y?
Oh. Will you just solve the equation?
Not that easy. because they've said y has to be greater than 0, does x have to be greater than y?
No. I mean, it's not. It doesn't have to. I guess we just have to
Well,
figure out.
5x's minus 4y's has to equal 3. So what I'm thinking is that if y has to be great, in other words, if y could be anything on the number line, then there's no way to tell whether x is greater than y with this one equation. But given that y has to be greater than 0, well, let's try some numbers.
Well, if you try 1, that's greater than 0.
Okay, so x would be what? If y was 1, this is going to be 4, so this whole thing has to be 7. So x is going to be bigger than 1, because 5x would equal 7, so x would be 7/5 greater than 1. So in that situation, it's greater.
Yeah.
How about if we pick a real tiny number like 0.1? Well, now 5x has to be equal to 3 plus 0.4, 3.4, so x is again 3.4 over 5. That's much bigger than 0.1. So it would appear with just two numbers that we picked that that would have to be true. And the reason it is notice that the coefficient in front of the x is greater than the coefficient in front of the y. And the reverse is true on number 2.
Yeah, I would say that number 2 doesn't work.
Okay,
well,
now
it would say
be a little careful.
Not doing y.
Be a little careful with data sufficiencies. There is a real tendency that if you come up with no x is not greater than y, the tendency is to say you can't tell. But when you come up with you can, yes. The first one answers this with an affirmative. Yes, x is greater than y. Well, the second one answers it. It just answers it with a negative. No, x is not greater than y.
So answer would be D if both of them work.
Yes. Now, I'm trying to figure out why this is so hard to answer. 5x is equal to 4y plus 3. You know, I can certainly see why x has to be greater than y by picking some numbers, but I'm not sure algebraically how to prove that x has to be bigger than y. Let's see, as long as y is because as long as y is positive, x was 2, this would be 11. I mean, if y was 2, x would still be bigger. If y was 3, I didn't try enough numbers. If y is, no, we're okay. If y is 3, x is equal to y. Isn't it? Let's see. If y is 3, then we have 5x equals 15, x equals 3. So that's all I need to know. I need to try two numbers. I tried 1, x was bigger than y. I tried 3, they were equal, so 1 alone does not answer it.
So from what we saw before, it's not true.
Was wrong. And the reason it was wrong is because I happened to pick numbers that verified x being bigger than y. Both numbers I picked. So that kind of illustrates a danger with picking numbers. you have to try to pick numbers that are going to disprove this if you can. I tried 1 and 0.1, and neither one disproved it. I had to go to 3 before I realized they were the same. Now it makes me rethink number 2. So let's look at 2. 4y minus 5x equals 3. Well, what does that say? That says 5x minus 4y equals negative 3. Y is a positive number. So in this case, if y is 3, x is bigger than y. If y is 1, x is smaller than y. So here we try x equals 1, y equals 1, which means that x is equal to what? If y equals 1, then x is equal to 1/5. And if y equals 3, we're going to add 12 to this side, making it 9. So x would be equal to 9/5, still smaller than y. What if y is 10? We have 5x being equal to 37. X is less than 10. So number 2 appears to answer it.
Why is 5 equal to 37? Because 10 times 4 is 40.
Right. So x is 37 divided by 5, which is a number less than 10. In other words,
you need 37 to get 40.
Right. In other words, this case, x was less than y. This case, x was less than y. And this case, x was less than y. The only number I might want to try, another number to verify, would be a number less than 1, like 1/10. How about let's just try that. So we have 5x equals minus 3 plus 0.4. So x would equal minus 2.6 divided by 5. It's a negative number, so x is less than y. So I've tried 0.1, I've tried 1, I've tried 3, and I've tried 10. I'm comfortable. In every case, x was less than y. So we can solve it with 2, but not with 1.
Yeah, usually just, yeah, okay.
30 should be B, and it is. Okay, that was a tricky one. It was a tricky one that's hard. I still not quite sure how to solve that algebraically. In other words, I still haven't proved to myself that x is less than y. It just was in 4 different numbers that were small, large, and less than 1. In other words, all the combinations that I was trying to think of. Okay. What is the one unique value of x?
Well, 1 is no.
Because that factors into x minus 3 and x minus 1. So you have x equals 3, x equals 1. The second one
is yes, because x is equal to 1.
Good. So this should be a B also on 32. And it is. 33. We got time for one more. 33.
If the length of the arc ACB in the circle above is 5 pi, is the length of AB greater than the length of CD?
So which one do we start with?
C.
2.
Yeah.
So the length of CD is 5. And that's the length of that line is 5.
Can't
And,
solve it with that.
huh?
You can't solve it with that.
No, that doesn't tell us much. And notice something else about this. They never said this goes through the center. That is not
Yeah.
the center of the circle. Okay, so 2 is a definite no.
Yeah.
And how about 1? The length of the line AB equals the circle's diameter. So can we figure out what the length of AB is based on that? If AB is the diameter of this circle, and if this arc is 5 pi, what's the circumference of that circle equal to?
Half.
Twice that, 10 pi. In other words, if AB is a diameter, then this is half the circumference. And they're telling us it's 5 pi, therefore the circumference would be 10 pi. And if I know the circumference, I can figure out the diameter. So that would tell me what AB is, but it doesn't say anything about CD. So 1 alone is a no. But if I consider both of them, what do I know?
You know that they're equally long.
No, not necessarily. But I know I can figure out the length of AB from number 1, and I can figure out the length of CD from number 2. Therefore, I can answer that question. Is the length of AB greater than the length of CD?
Yeah, so all you have to say is, yes, you can solve it. The
And
answer
that's
is
it. That's it. So C should be the answer on 33, and it is. All right. Shall we stop there? The next data sufficiency we'll go to is 35.
Okay.
Yeah, I think this works a little bit better. We're going to run out of problems faster, but we'll make sure we get more practice in data sufficiencies, which I think is key, although I also think it's very much of a key to go through these underlying math principles that these tests are based on. And I think we'll have time to get through all of them. There's not that many subsections left. Let's see. Yeah, I don't have it up here anymore to look at, but I think there's only like 4 left subsections, and we go through one of those per half hour, so we should be in good shape, I think.
Okay.
Okay, I will talk to you tomorrow at 4 o'clock.
Yep.
Okay.
I'll talk to you then.
All right, Cecilia.